Welcome to this video lecture on the topic of correlation. As the name suggests, correlation explores whether there is a relationship between two sets of measurements. For example, if I observe the ages of cars that are for sale and the prices of those cars, I will find that as the age goes up, the price goes down. There is a relationship, and that can be useful for predicting what the price might be for some car that I want to sell. If I know the age, I can identify what the price might be. So in order to find out if there is a relationship between two variables, we can plot these two variables on a scatter plot, and it's quite easy to see by eye if there's some relationship there. We can also measure the degree of correlation using the correlation coefficient. The correlation coefficient is a number in magnitude no greater than 1. Even if the graph shows a perfect straight line sloping upwards, the correlation coefficient R will be 1. A straight line sloping downwards, the correlation coefficient will be -1. But if there's any amount of scattering the points, then of course the value of R will not be exactly 1 or -1, but maybe close to 1 or -1 if there is strong correlation, or close to 0 if there is little or no correlation. Even more useful than R is R², which is called the coefficient of determination. The coefficient of determination is usually expressed as a percentage. And better still, R² adjusted estimates the value of R² for the population. For example, if I explore age and price data for some cars, as is done in the textbook, I find that the R² adjusted value is 99%. This tells me that 99% of the variation in the prices can be explained by the variation in the age. So if I look at some cars for sale on a website, I will notice that some are quite expensive, maybe 14,000 euro, some are quite inexpensive, maybe 2,000 or 3,000 euro. And I might ask, why is this? The answer is, it's because of age. Age explains 99% of the variation. The other 1% is not explained by age, but explained by other things. So that even if a number of cars are the same age, there will still be some variation in their prices. And that variation is measured by S, the standard deviation, which in the case of the textbook example was 407 euro. It's the typical difference between the price of an individual car and the average price of all the cars of that age. You can read all about this in section 6A, correlation, in the textbook.